of q squared. So bringing the multipliers up as the exponents. So now I'll work inside parentheses. Next, I'll just go 8 minus here, because I've got the two logs subtracted, I can write them as a single log of a quotient. So that will become the log of p to the 4th over q squared. Parentheses are gone. Now I've got another subtraction, so I can bring these together as a quotient. So that would be the log of 8 divided by this fraction, p to the 4th over q squared. And now it's just taking care of this ugliness here and carrying the log along. So if I make this 8 over 1, got a fraction divided by a fraction, I'm going to flip and multiply and carry along that log. So if I flip that over, that will give me 8q squared over p to the 4th. Well, let's see if we got it right. Yeah, we did. Okay. I didn't sound surprised there at all. Okay, next one. I'll find my notes. Right here. All right, switching gears after I turn my phone off. Maybe not. Okay. Next one. Now I want you to expand this one as much as you can using the properties. So the first example, we brought them all in. Now we're going to expand it as much as you can. So we got the log of u squared over v times w. Okay, so we want to undo this stuff in here. I would undo the division first. And the division, when you have a quotient, that goes to a subtraction. That would be the log of u squared minus the log of v times w. Okay, now we take care of each log. What I can do to expand this is bring that exponent down as a multiplier. 2 log of u minus, and here I've got the log product. And because I know the log of a product goes out to two different logs, I know I need a parenthesis here. So that would be the log of v plus the log of w. And again, it's just I had the log of a product goes to the sum of two different logs. All right, example 4. Evaluate. That just means pick up your calculator and get me a number for this answer. Just going to do one of these. We've got the log base 5 of 7. Okay. Some of you can do this, just type it in. I don't know where your log button is. I can't remember. I'd have to look at the calculator. But if you have my operating system, you don't have a log where you can change the base. You've only got log base 10 and log base e to work with. So what we have to do is use that change of base property to rewrite it. So the change of base, I'm going to choose to use the log base 10 button right here, expand it to this. So it's the log base 10 of x divided by the log base 10 of whatever this base number is. So here, for me, that'll be the log of 7 divided by the log of 5. So, real simple now. Log of 7. Notice a parenthesis came up when I hit the log button. I've got to close that. Divide by log of 5. So, about 1.21. So, just don't forget to close your parenthesis after your number. Alright, and the last set of examples are going to be solving log equations. Okay, first one. We've got 4 natural log of x equals natural log of 16. So what you want to do, because you've got a natural log on both sides, is get the natural log of something on each side. So you want to simplify this side here because it has that multiplier. So what I'm going to do is bring that 4 up as the exponent. Leave this side alone. And now if you look at it, I've got the natural log of something equals the natural log of something else. Well, in order for these two natural logs to equal each other like we've got, what's under each finger has to equal each other. So now that I've gotten it to the log of something equals the log of something, I can just ignore the fact that I've got these logs here and just say x to the 4th has to come out equal to 16 in order for the two logs to equal each other. So at this point, I can just ignore the natural logs and say x to the 4th has to equal 16. And now it's your simple algebra. To undo the 4th power, remember we just raised it to the reciprocal, 1/4. Because that's going to bring us to x to the 1st when we multiply those exponents. And then the 4th root of 16, 16 raised to the, I'm going to go 0.25 because then I don't need parentheses, 2. 2 to the 4th power is 16. Okay, let's try another. Over here. I've got log base 4 of x equals 5/2. Okay, at this point, I'm just going to rewrite this one, because I don't have two logs going on. I'm going to rewrite this using the very first property that I gave you, the rewrite. I'm going to rewrite it as an exponent problem. Right here. I'm going to use this one. I've got the log base b of something equals something. So I know that the exponent is what the log equals, so I'm going to rewrite it in exponential form. So the 5/2 is my exponent. Remember, the log equals the exponent. So it's 4 to the 5/2 power equals x. And then if I want to pick up a calculator to do that, 4 raised to the 5/2 is 2.5, 32. Try another. We've got natural log of x plus natural log of 3.75 equals natural log of 30. Okay, and it's just working. Because these both are numbers, I would bring those together on one side, leave the x on, isolate the x. So I'm going to subtract natural log of 3.75 on both sides. So natural log of x. Now I'm going to combine these because I've got the natural log of something minus the natural log of something. I know that those combine into quotient. So it's the natural log of 30 divided by 3.75. Now I'm right back to where I had the first problem. I got the natural log of something, the natural log of something. I know that those two somethings have to equal each other. So now I know these are gone. I know x has to equal 30 divided by 3.75. Grab a calculator. 30 divided by 3.75, 8. Let's see. 2 left. Trying to hit everything here. Let's go one more of these. D. Last two are a little bit challenging. Well, no, they're not. I'll go this one. 7 to the x, the last one's going to be challenged, equals 4. Okay. This is the first time we've had the x up in the exponent. Okay. We can't solve for the x when it's up in the exponent. So what I can do, hit it with the log and knock it down. So what I'm going to do is take the log on both sides. Then I'll be able to use that property 3. So if I take the log of both sides, which is legal, and this could be just as easily be a natural log. It doesn't matter what base I use. I'm just going to hit it with the log, and it's the same log on both sides. I use log of 10. Now I can bring that x down as a multiplier. Now to isolate the x, get it by itself, all I've got to do is divide by the log of 7, because that's being multiplied. Okay, now don't get confused. There's no property that lets me subtract these. Remember, this is where people make the mistake. I need the log of a quotient. Here, what I have is a log divided by a log. None of these properties apply to this. But all I've got to do is grab my calculator at this point and do the log of 4, close parenthesis, divide by log 7, 0.712. Or I could have left it log 4 divided by log 7 if I wanted an exact answer. Okay, so if your x is trapped up in the exponent, hit it with a log on both sides to knock it down. So a log knocks the exponent down. All right, last one. Little algebra in here. We've got the log of 2x squared minus 11x minus 40 minus the log of x minus 8 equals the log of 16. Okay, so I've got the two logs with the x's together on one side. What I want to do is combine them so that I can solve for the x. So I see the subtraction. I know that these two can come together as a quotient. So the log of 2x squared minus 11x minus 40 divided by x minus 8 equals log of 16. So I've got the log of something equals the log of something. At this point, I can throw away the logs and say that this ugliness has to equal 16. But I've got to solve this. Well, I'm going to take a stab in the dark here because this is doable and say that this factor's up here. I'm going to bet x minus 8 is a factor. If I think, well, I'm just going to try it. Put an x, let's see. I need to get 2x squared, so I know I need a 2x here. And that'll give me my 2x squared. I know I need to get a negative 40 when I multiply the last by the last. That would be a plus 5. So if I check to see if I get a negative 11, I would get 5x minus 16x. And 5x minus 16x is a negative 11x. So it does factor. Cancel those out. That leaves me with 2x plus 5 has to equal 16. Very simple algebra problem to solve. 11x equals 5.5. Okay, what I have for you is a worksheet. It's a 9-2D and a 9-2C. We're going to do evens on both sides for homework. So it's a worksheet, evens. Okay, that's it.